It doesn't seem.
This meeting is being recorded.
All right. So what are we? This is about a new open source external debug that on the open power, the problem with open power is the original PowerPC debug, they had a circuit that worked like this. So you have JTAG, and you have a debug module that basically can stuff individual instructions, bypassing the fetch right into the instruction engine. And then you do a step. And in that way, you just force feed the actual execution unit in the processor by whatever instructions you want on the client debugger side. And that way you read registers, write registers, read and write memory, step, and so on and so on and so on. Now, with the fully open source power, there's a problem because that circuit is not open sourceable. So the Microwatt people, Microwatt is this small implementation in VHDL which serves or is supposed to serve as the reference implementation. So they did a nicer debug circuit that is based on what RISC-V people are doing. That's the DMI thing. So it's a DMI stands for debug module interface. So you have a debug module and you have a bunch of signals or a bunch of wires between that and this DMI thing, which is an interface through the JTAG to this thing where you can stop the core, step, restart, read registers, write registers, read and write memory, set breakpoints, and so on and so on and so on and so on. It's all fully open source. The problem is it is only very, very beginnings. So almost most of the stuff is actually not implemented, just bare bones. And the other problem is, well, there is no software support. So you cannot really debug because you cannot connect GDB to it, because for that you would need some kind of bridge between RSP and this DMI JTAG thing, and it does not exist. So we did a couple of things to rectify the situation. Jan wrote a small bridge between RSP and JTAG DMI based on the reference thing that the Microwatt people provided. On the client side, just as an example, I guess, to drive this from the command line. And what I did, I wrote a little bridge between the ULD debugger and the DMI thing. So now we can actually debug things from whatever, if you want from GDB, if you want from ULD, from whatever places. So it's very nice. The question is this any good for real life debugging? So we're gonna try debug some problems. There must be some problem in the chip itself. because when we try booting, like flashing Microwatt on this very nice Genesis Kintex board, it does not boot. We cannot even get into the U-boot bootloader, let alone load Linux and try running Linux. Nothing works. No, you cannot even start. So somewhere very early there is some fundamental problem with the SoC. And so far there has not been any toolchain support for that new debug circuit. So what we're going to try to do is we're going to try to connect from, well, we're gonna see, because one problem with ULD is that the bootloader is a C program, and the problem is symbols. So you cannot really do that, and I wrote a little bridge to libgdb.a. So over FFI, you can do things like, okay, well, look up where this program counter is, which line of C code is pointing to, and then you do that. That's one alternative. The other thing we're going to try is actually connecting GDB. And if you have GDB on top of RSP, then obviously you have all kinds of nice IDE debugging, like from the Eclipse CDT, you can debug things and nice graphical stepping, whatever, high level IDE-ish things. So I guess, well, this is just us and Leandro, so this was an introduction. Jan knows all these things, so this was for Leandro and for posterity, whoever is watching this hackathon. So obviously the people who will be watching the recording cannot ask questions right now, but Leandro, do you have any questions?
Not so far.
Okay. Perfect. So let's do this then. I have prepared a couple of images so that we and we are gonna do those. So let's do this. This is gonna make a horrible noise from the fan on the board, and I'll flash the standard gateware that is at the upstream master. So like this. No, that's not what I want. What I want is something like this. No, maybe. It has it in history. Okay, better. So first I'm gonna flash to the board the actual Microwatt. So that's the configuration bit stream, and I have built a few ones. So this is the upstream. This is the clear thing, and there was a problem with this where the top mechanism would fail, or the selection of the FTDI chip would fail on this board. So I had to use one of these external JTAG cables. And yesterday, Jan fixed that. So now we have the luxury of not switching cables around and just use the nice circuit that is on the Genesis board that hosts the Kintex chip. Okay, so this is, we are pretty much there. And then I need to, while this is finishing flashing, I'm gonna build the U-boot. So make clean. So this is, if you look at this, this is just this is just Schenke's upstream U-boot. There's no change. This is what is upstream. So we're gonna build that. So we clean, then we do what? We apply the default config for the microwatt on the RT. From a software perspective, that chip should use exactly like this. Modulo that obviously it doesn't. We have some kind of problem with the chip, and or with the SoC, I should say. So it does not. You will see what happens. So okay, so that made, and then we're gonna do output into this build directory, and I'm gonna use this so it's really fast. Right. Okay, that built. Now, right. So that just built, and now we're gonna flash this. So U-boot, where was I? I was just Q-flash U-boot. Is that where I am? Yes, that's the upstream U-boot. Okay, now at offset that you see that minus A 125 82 blah 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 blah. So that's in the same QSPI flash chip. That's an offset right after the bit stream comes the bootloader. And now, so I like color coding my console to see what is where. So if I like this and I screen the TTI USB 0, that gives me the console, and then I'm gonna power cycle the board. The UART gets power from USB, not from the not from the board on which it's sitting. So the screen survived the power cycle, and now the Kintex is a pretty large FPGA. So it's the configuration itself is very fast, but the QSPI flash. Okay, right. So
Good.
this is the status. So this is this is what happens. Oh. Interesting. So it fails to boot U-boot, but it didn't even recognize the start of the U-boot. So my My suspicion is that what did I flash? So I flashed.
Oh, you flashed the upstream microwatt, right?
That's the upstream, as opposed to the one I gave you last night,
Yes.
which has the fixed SPI.
Yes.
Right. Okay. Do I still have it? Well, let me compare. So what did I flash? I flashed upstream. Okay. So so that's that. And the one I gave you last night was I think this. Yeah, that's the same.
Okay, let me check what's the SHA here.
Yeah, what's the MD5 on your on the one that is working for you? Maybe we flashed some idiotic. Well, it is this U-boot thing, and the offset is right. 125, 82912. That's the correct offset.
Well, my SHA is it's not a SHA, it's an MD5, right?
MD5, yeah.
My MD5, from what I've got yesterday.
Yes, the one that does work, right? The last one.
The last one that works, that actually, loads the U-boot, is a B5CO A2 and so on. So it's a different one.
Oh, it's a different. Wow. How is that possible? I was pretty sure. Can you give me like on over Slack? Can you give it back to me?
Oh yeah, sure. Give me a sec.
If we go to post it in the on the VM channel.
Yeah. Let's.
Who else promised to come? Mark Ingram. Okay. Well, he's not here.
He's here.
So...
Mark is here, Boris.
Mark is here? Oh, hi, Mark. Oh, okay. Oh, yes, that's right. All right. This. We're gonna just put it in there. And done. So we're gonna flash this one. And when that finishes flashing, Okay, and then I'll just cycle this, see what it picks up from. Takes like half a minute. Oh yeah. Oh, right. Perfect.
Yeah.
And at this point, I'm not even sure that it copied it right, that we have that we actually have the right bits of the U-boot binary at that offset. Does it go there? So my plan was to put a breakpoint, or well, not a breakpoint, but a cycle in which we can stop and then step out of it, because we don't have breakpoints yet in the actual first stage firmware, and then follow the jump. But now I am hearing from Jan that oh, now I have a backtrace in U-boot. Does that mean that you connected GDB to U-boot running?
Yes.
Okay, so we know that it is in fact jumping to U-boot.
Well, let's say it is somewhere in U-boot. Whether it's on a correct place or not, I don't know. But it's in the address. So when I load because if I remember correctly, the U-boot, when it relocates here, it relocates itself on itself, right?
Yeah, but before that happens, it initializes the console, it prints a
Yes, and
banner with its
somewhere,
version, it initializes the debug console, and so on and so on and so on. None of this is happening. We're dying much earlier than the relocate. So anyway, let's do this. How about this? How about this? We do something like this. We open another terminal here, and we go to I have, for example, so this is the reference thing, right? And oh,
well, now you are going to be a little bit screwed because here you don't configure the URJTAG properly.
You can look. I found this last night while fixing the same thing in ULD. Look, in the JTAG backend, right? This is what Shanti wrote. You see, when you probe, or if nothing, then it probes, right? But if there is, then we pass them these parameters, right? These are JTAG cable params.
Oh, I see.
So
okay.
What we do is, what is the usage? How do we pass them? It should be this is a help. Oh yeah, okay. So minus B JTAG, and then how do I? Okay, that's lying. That's lying. That help is lying. There is another one. There is what was it? Let's look at it again. So the parameter is what? Target. How does it compute the target? Oh, okay, it's whoever calling JTag init. So command JTag init is this, and it already has target. So bscan e2 oh, right. And this guy knows the target. Okay, minus T. Right. And how do you pass it a multi-thing? You quote it? Like here is opt-arg, right? But opt-arg get opt. Oh, okay. That's the read line stuff, right? So it should recognize quotes.
Yeah.
Okay. So minus T, and in quotes, how was it? dglent hs1, right? hs1.
No.
Can you
Hello.
read back what you wrote last night?
Yeah, let me fish it out.
Interface equals 1. I have
interface was 1, index was 0. I'm not sure index is necessary, but won't hurt.
Interface equals 1, index equals 0, like that.
Yes.
Yes.
Good.
And this 0C02D888, that does look like where the firmware is loading U-boot into. And this,
and that's exactly the address when I tried like a half an hour before we started. When I just that's where it stopped for me as well.
Okay. So.
But did you compile with minus O?
Minus O0.
And
minus O0 minus
GGDB minus.
Oh, wait. That's bad. Because this one, look, this is the pristine for DMI hackathon. I cleaned, and this is the upstream. So we have to recompile. Yeah, you see that? Minus O2.
Yeah,
so
that's
I'm
not good.
gonna go minus O0, and this
minus
is gonna
GGDB3.
be GDB. And what did you say? Minus
F no line.
No dash in line, right?
Yes.
Assembler doesn't inline, so that we're fine like this, right?
Yes.
Okay. And let's clean it. Let's reconfigure it again for the RT, and then build it. Right? So
and
we have that, and not this, but the U-boot. And then we will, okay, and I am power cycling the board. Okay. Did that? No, not yet. Okay. Oh, now.
Okay, now we
Right. Now we are in that's a different address,
That's a different address, but it's a different U-boot.
but it's a different U-boot. Yeah. Yeah, it does look like it is U-boot, and it's looping somewhere, I guess, because look, it.
Yeah, well, what I did is that I just attached a GDB, and it's in some weird reading from the UART or something like this.
Okay.
Or writing to UART.
Here's a couple things we can do. So let me show you. I have here a ULD
Yeah, this is what I'm
error
interested in.
image.
Yeah.
So, and this is a rough experiment I just did last night to link to libgdb. So let me show you what this does. So how about this path to elf? No, I don't want the. I thought we were gonna be stuck in the firmware, but we're not in the firmware. We are already in U-boot.
No, we are already in U-boot.
So this we want this. All right, and now let's see. So let me show you what this test does. So this guy, he, so this, that Pocho's terminology, right? The mother Smalltalk and the baby Smalltalk in ULD. So this is not a baby Smalltalk VM, this is a baby C program. And what that does is this ULD-C is this thing, let me show you what it does. So it links to libgdb. And that thing just calls gdb init. That's all. Is that normal? Should I have?
Yeah, that's normal.
Okay, let me just, you know what? Let me restart this image again, because somehow this libgdb.a connections, sometimes they survive, sometimes they do not survive things. So let me show you. So the file path is the U-boot. So we'll have to trust that that creates a GDB thing, and then create Microwatt GDB. That's just this initializes is the one, and the Microwatt JTAG that just let me show you what it does. Right, so this is your fix from last night.
Mm-hmm.
That's it. And then the core is still running, so we haven't stopped it yet. We haven't done anything. So there is We have GDB there, and then we do stop, because if we look at the baby, nice thing, but what I want is actually the GDB. And if I ask him the status is running, right? That is true, right? And now when we stop the core, okay, somewhere there we're gonna see. Now the status is, no, I want GDB, and the status of the core is running is false. So now I can look at things. I can look at registers, and it's my program counter. Interesting. Oh, right, because on my on the DMI program counter is kind of special anyway. But we have, right, we have the assembly where it is. Where, let's see where. I couldn't get it to show a particular line, but oh, in 8.
Exactly. This is where I got to. Yes.
Yes. Okay. Well, I would like to see a backtrace, which this thing is very nice, but it's not giving me backtraces. You have one running?
Well, I can just power it on.
Yeah.
But you might see, sorry, you might hear a horrible background noise.
Well, you're listening to my horrible background noise, which is like right next to the machine with the mic. So
I put it on the table and try to do something. Let me power it up. Okay, do you hear it?
No, I don't.
Oh, good. I hope it won't catch fire. Okay, let me try to start the debugger and things. Okay. So what do you want me to do? I got the backtrace.
Do the same in GDB. Yeah, post the backtrace in the chat.
But now I have it in a slightly different backtrace than I used to have. Probably hit it in a different. But anyway, let me post the backtrace, right? Copy contents to clipboard and to the VM channel.
Yeah, VM channel is fine. The chat of the the chat of the meeting is fine too.
But that would screw the. Ah.
Oh, so it is in read byte.
Yeah.
Okay, so it's trying to probe. It's trying to probe the UART.
Yes.
And in it. Okay, let me do this. Let me. Oh, this screen. Okay. And the other one is where I have my boot. Okay. So it's in NS 16550. That is NS 16550.c. Right, that's the serial drivers. Okay. Like this. And then right. So in the init, okay. So right, that's the line status register in the 16550, and when it like before trying to output any characters, it looks, because this is a polling driver, right? So it when the UART is transmitting, it has this transmitter busy bit on, and here we are just polling until until the output byte is empty, and it thinks, oh, serial in gives this read byte. Right. It's just yes. Yes, 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 yes. Oh, I see.
Good, because I don't.
Right. Right. It's more stupid than the firmware. That's the problem. So in the firmware, hang on, maybe I'm wrong. Maybe I'm wrong. Let's read what. So it's in microwatt. Hang on, I'm not sure where this is. Is it in? So it does it when the firmware, when the first stage firmware reads or writes to the console, it does this printf, and then it is, I think it's in, yes. Oh, yes. You see, this is clever. So it has this UART is std. So first, it reads a syscon register, and there is a bit in there that defines what kind of UART it is. Is it a 16550 or a potato? And it's clever. Now, in the U-boot, it's hard-coded that it's a 16550. What do we have on this SoC? So that would be in microwatt.core, and here is the Genesis node. No, that's not the one. So what do we have on the RT? On the RT, that guy, UART is 16550. Now what about Genesis? And on the 7100, it is also 16550, right? And you would just assume. Now on the Genesis, that's the no DRAM. We don't want, we want the one with the DRAM. It is, UART is, shit, you see this?
Yes, I see this.
You see this? That's potato, not the 16550. I bet if we get rid of this and put it like this, and then here, there is my build directory, and I'm gonna build and this. Okay, this is gonna take a bit of time, but I bet that it's gonna actually
yes,
make some kind of difference. Okay, so right, import the sources, and then synthesize the process. Okay, well that's gonna take a little bit of time. Does anyone have any questions? Because this is gonna take like 10 minutes to synthesize. Oh, hi Juan.
Hello.
Hi. Nice,
Okay.
nice seeing you here.
Same, same there.
Yeah.
I don't really know much about what you are doing, but it's nice to be around you folks from time to time.
Neither I do, Juan. No worry.
Okay.
Maybe, Boris, maybe it would be good if you and Jan tell us some objective or goal for today's hacking.
Today's objective is to see whether these debugging tools, such as in ULD, we saw where we are hanging, right? And whether this debug support is good enough to do anything real, like to progress in fixing any real problem in an SOC. And we will see whether the bootloader is gonna get any further with what we just gathered by looking through me looking on my side and Jan producing the backtrace on his side, because it's been like a couple of years and nobody in the community was able to progress beyond this, just beyond this thing just hanging without not without understanding what to do about this. And there are no debugging tools. There is nothing. And the hypothesis is these debug tools that Jan and I are doing, in this Smalltalk project, that they are actually useful. And if we can make any progress, if we can, then our tools are useful. And if before the end of this hacking we have no progress, then we are full of shit and our tools are not useful. And perhaps this whole vertical approach is not useful, and we have to go back to the drawing board. And if we cannot make any progress today, then it means simply that maybe this whole, this verticality story about the thing that the VM is not horizontal and not a delineator between layers of software and hardware, but a vertically slicing thing. Maybe that's just, maybe I am completely wrong, and just we should be doing whatever somebody else is doing. So we'll see. This is in that sense, this is live thing, right? We're just coming up with the debug circuit, and I'm sure it is full of all kinds of faults. I mean, like 10% of it is even implemented. You cannot do a breakpoint. You cannot continue. You cannot. Well, you can step, but it's not much use. But even with this, right? It's how you live on the vertical bleeding edge, not just the bleeding edge of your own layer, but because here nothing works, right? The processor doesn't work, the SoC doesn't work, the debug circuit doesn't work, the debugger doesn't work, right? The lowest level GDB server debug bridge does not work. The support in the toolchain is non-existent. ULD has a bunch of layers. None of that works. And it's a completely different world from a horizontal world where, well, you assume that the chip works and the operating system works and you have, you know, compiler, like you assume that GCC works. And if there is a bug in GCC and GCC is producing bogus code, you are basically stuck. And the whole way how we design software is such that it's that way by design. You cannot easily fix it. Well, with this approach, what I showed you in the ULD, if any of that level breaks, it's easy to fix. But maybe it's not. We're gonna find out in like a couple of minutes when this finishes. Of G insertion. So this is, oh, this is placing already. Okay, right. Yep, it's almost done. Oh, no, it's, okay, it's, right. So it placed. So now it's gonna route. Okay, yeah, that's a couple of minutes.
But, you know, speaking of debugging support, I see an interesting pattern, you know, reappearing. Remember years ago when we were trying to make the Testarossa running on RISC-V. You know, we couldn't make any progress until we got to work in GDB.
Yes.
And couldn't really see what's happening.
Yes.
And you know, here you were stuck for 2 years without actually knowing what the thing is doing, and not knowing where to look. And now, as soon as you have a debugger, so you can actually see something. I'm not saying we fixed the problem, but at least we have new ideas what to try. Let's say.
Yeah, well, we're gonna find out real soon now.
I feel optimistic, but we'll see.
Well, of course, it's one. I mean, it for sure it's one bug. I mean, I'm not saying that the SoC is completely screwed when the UART is the potato. But a couple of things, right? U-boot doesn't know anything about the potato. And number two, support for potato has been abandoned for, I mean, it's still in the firmware, and the firmware boots fine with the potato, but I wouldn't be surprised that there are, you know, that there is rot in there.
Well, let's see whether we will get at least some message from U-boot.
We will see. Yeah, we will see.
So let me help me understand at what stage of this process toward that goal are we right now? So we are setting up the debugging platform, right?
Vertically everywhere, yeah, because we don't have a debug circuit that works and has been tested, and this is the first time the actual circuitry for debugging the core has ever been put to any real use. Okay, moment of truth, and I'm sorry, Leandro. I really want to see it. I really want to see it. Okay, so so we need to flash not this. We need to flash
not this.
Not this. We need to flash this. and then build, and then microwatt 0, and then Genesis, and microwatt 0.bit.
Mhm.
This is the new one.
I hope so.
What happened?
Well, you have to disconnect your image.
No. Oh, in Smalltalk, right. The ULD has, yes. The ULD has monopolized the JTAG. Okay, I'm just gonna save and quit here. Yeah. Nah, better. Right, and then I'm gonna them side by side like this. So this is still writing. So this is gonna be our new supposedly fixed bit stream and still the upstream U-boot. Okay, moment
Yes.
of truth. Off and now power on. Takes about a minute to boot.
Very good.
What? What?
No.
No, but it's worse. Hang on, let's try it again. It's worse than it was, right? Okay, how about I put the U-boot in there? It's worse than it was because it's not even trying to. It's not even trying to jump to it now. Okay, how about do this again? No, this is not possible.
Well, could it be that the bitstream is too big?
It shouldn't. No, look, Jan. If it says copy segment 0, then it parsed the ELF, right? And this guy, this C0000, right? That is the text, the beginning of text that it gets from the ELF header. So it did actually.
No, not really, because there is the ELF header. It's few bytes above it.
Say it again.
Well, at the 0xC 0, 0, and so on, there is the whole ELF. So there are a few bytes of the ELF header.
I know. That's not the whole ELF. That's the text segment. So it looks at the ELF header. It finds the... Okay. Oh, I know why. Right. This is, I don't have, oh, crap. Okay. I know why. Oh, damn it. I know what's going on. Okay. I don't have, this is what we synthesized is not the pristine upstream. This is the one from which I was preparing for looking at what's going on. So there is a breakpoint that I inserted. Look at this. Light DRAM gen source sdram init main.c, and I put in this loop forever thing.
Oh, okay.
That's what it's doing. We don't, okay, but that is trivial. That is actually trivial to fix. So I'm gonna go to ULD again. I am going to go there, put that, like, you see what it's doing here? It's, right, there is this loop forever thing, and it's 0. So if we change it to 1 and then continue, then we are gonna see something. Now, so let me see about my hypothesis. So we're gonna stop, and let me see where I am.
Mm-hmm.
So, assembly. Oh, right, because I'm in the bootloader, not in U-boot. Right. So I'm gonna get myself here again in the bootloader. Oh, how I hate this arrow thing where it thinks it's more clever than you. Yeah. Okay, so that I'm gonna restart my barrel because I don't know with the GDB thing. So okay, am I stopped or what? Oh, here is the main C. And where am I? I am. Yes, look.
Nice.
Right. So loop forever. I can look at what it is. So it's 0, right? And then I can change things. And now if I look at it, now it's 1. And then
Hold on a second.
yes.
How do you know what is the type of it?
I don't. I assume it's 32 bits.
Okay. So you just take an address and put a 32-bit word address with
Yeah.
a value of 1. Okay.
Yes. Yes.
But
It's
if it would be
really,
byte,
really hacky.
if it would be byte, you screwed.
You're screwed. Yes.
Okay. Okay.
So where is my GDB? GDB is this. So I go continue.
Mm-hmm.
Right? G. Am I? What is my? Is running now? Is running is true. And what's on the console? Look at that! Look at that!
Wow. Wow.
Look at that!
Okay, job done.
Well, okay. It misdetected the size of the RAM. There is a gig of RAM on this board and not 256 megabytes.
Yeah, but
And,
that
it-
goes from DTB, no? From device 3.
Who knows? Yes, it should be from the device tree, or
Yeah, but the
it
device
should,
is
I'm
compatible
not
with
sure,
YouTube.
from Syscon or from DTB or from whatever. Who knows, right? Everything is broken. That's the rules of this vertical game. Is nothing works. So who knows? DTB may be broken, or if it's not looking at DTB, but at the Syscon, maybe the Syscon is lying in the chip. Maybe the code in U-boot is misinterpreting what it's reading. Who knows, right? But what I'm saying is that we just went from this where nobody knew what the problem is, to a state where, well, something at least something appears to be alive.
Well, I think the U-boot is alive. I mean, you can try a few commands or help or something, but
Yeah.
it detected Ethernet.
Yeah, it's alive. It's alive. Okay, well, that patch is going upstream, that for sure. Now, Ethernet is a completely different thing, because what it said about boot P is complete crap, because the Ethernet chip is not even wired in this SoC. But I mean, I'm happy about this hour and a half.
Well, that's at least some success. But now we can
Success. Yeah.
look. Do you have, just do you have a Linux kernel compiled for PowerPC? So we can, instead of U-boot, we can flash the Linux kernel, just like we did with the, like we did with the ARC,
Yes.
and see whether we are going to
Kernel. I have it. I don't know where it is, but it's
Okay.
yeah.
But anyway, maybe we can get back and answer Alandra's questions. I have to leave in 10 minutes anyway.
Well, yes, and the academic group, they invited us to join their call. That is in 8 minutes. So if anybody wants to move over there, then we can move over there. I can post on the Slack the URL for their meeting. If not, we will just answer Leandro's, keep answer or provide the second half of the answer to Leandro's question. And then we would say, yeah, we are pretty happy for today, I think. Like, well, at least we're not completely full of shit when we say this approach to debugging.
Not completely, yeah.
yeah. Yes, so where we are, yes, that we have nothing, right? We have external debug circuit is just, you know, a bunch of hacks, and they don't really work. The bridge between debuggers and that circuit, well, Jan spent, what, just hacked it together in, I don't know, in an evening, right? This up from it, there was nothing. Like the open source toolchain knows nothing about this chip in terms of debug. So the thing is that when you're working like this, all of these things, they are each, you know, half an hour. Whereas with a traditional horizontal approach, you are simply completely stuck. If something is broken at a level which is not horizontally the same level as what you're working on, you are dead. You cannot do anything. If you're making a VM but the processor doesn't work, well, you are dead. If you are doing something in the image but the VM doesn't work, you are dead. So that's what was that what you were asking, Leandro, or maybe I misunderstood your question?
No, it's okay. It's hard for someone like me who is not familiar with all these things to understand the process you are trying to follow and at what stage we are right now. I understand you guys achieved some success today, but it's hard for me to have an idea of how far we are from actual debugging, having the debugging platform.
Well, it's enough of a real debugging platform to have fixed the problem that was preventing the bootloader from working at all. So I would think this is a pretty useful debugging platform as it is right now. Do you agree, Jan?
I do agree, but let me try to answer Leandro slightly differently, or using a different point of view. What we are, the question we have, or we had, was like, for years we are working on these debugging things, and as you may know, we are trying to use not only open source Smalltalk and VMs, but also open source hardware. So the question was, the tools we originally developed to debug, let's say, VMs running on top of an operating system, are they any good to help us when we have open source hardware running, for example, on top of it, now we run U-boot, but you can flash, let's say, a bare metal enabled VM. Are these tools good enough to help us with that? And now I dare say they are good enough. They help. So that was the thing. If we find out that it doesn't help us, then our tools would have to be rethought or redesigned to help us in that goal, having the whole stack from the very very low level hardware to up to the VM and image about it. Does it make any sense? I don't know.
No, it does. The reason I keep asking about an idea of progress with regard to the final objective is because I keep you both saying we still don't know whether this approach or tools we have are useful or not. So a simpler question would be, the progress you made today gives some hope that this is actually the right approach and tools?
I would think it's a pretty hard proof that this is the right approach. Like with these tools, we were able to make progress that nobody else could make with traditional tools. That to me looks like a proof of usefulness of my tool.
Yeah, I agree. I mean, it's like, back then in Cagliari, when I shown the VDB first time, people came to me and they were like, "Oh, well, this is just for Smalltalk-X, so it's useless." And since then, I started using it with B, and hopefully demonstrated that maybe it's not that nice, but still usable. In Toronto, I decided to show it on Java, not because it's something so great, but more because it's a completely different use case. So it's another kind of, I wouldn't say proof, but demonstration that this approach is more general than debugging just Smalltalk-X or just Smalltalk. And now this is just another case when this approach, obviously we generalize things and modify things and redesign things a little, but the general approach now we use to debug memory, DRAM controller, firmware, and bootloader. So this gives us a bit of a confidence that, as Boris says in his typical way, not full of bullshit.
Okay, excellent. Okay, guys, I think we could we can stop the recording now because you have to go. So I will stop here.